Hello, welcome to the update on Meta Information Project. It's been a while since the last one, so let's just jump into it. So what do we have new in the project? So once again we inspect entities like issues, pull requests, readmes, and etc. for a repository on GitHub. And as the time goes, these entities grow. The list of these entities grows up. So we want to inspect more. So for example, we want to inspect, let's say, commits in particular files, or the usage of some managers or GitHub plugins, and etc. So we needed to have a more concise structure of a MI project so that the implementation of a new entity would not be a mess. So anyone who does not know anything about the project can contribute to it. So we've come up with a new concept of having having a standalone module for each entity. So right now we have inside of the MI project, we have entities subfolder, and there the entities are implemented. So the main one is the entity object from interface, and the other are inheriting from it. And we have also a template module, so that when you want to start, implementing anything new, you just copy the template module to your desired entity. So I can probably do some quick live code with this, and I can show how it's done. So let's say I want to have a inspection on the dependency update of dependencies in repository. So I'm just going to copy template to the let's say to the new dependency update module, and I can start doing implementation. By the way, can you see the code clearly, or should I zoom in?
I think it's clear.
It's clear? Okay. So right now, the template entity has all of the methods you should implement when you want to inspect an entity, and you don't have to do anything else. So so let's just name it a dependency update, and we can start. So the important thing is to have a schema defined. So the schema is basically a checker that you extract the information from the entity right, and so it's just a way you want to extract all of the information. So I can start by doing a schema of the dependency update, which is basically all of the commits to the pip file, log file in repository. So the schema would be probably like the user who has done an update, and well, we can say a date when the update was done, which is a timestamp. Now, probably this init file will be removed because it's not important, because every entity should be initialized with the repository and nothing else. So yeah, I don't have to do anything there. The analyze function. What does the analyze function do is that it basically returns all of the entities that should be inspected. I will return into that in a minute, but I will first show the other functions. So you have also the store function, and that is the way that you want to store the knowledge inside the schema. So basically, we want to inspect commits to the pip file log file, and that is a object from GitHub because we are using that. And let's just say that we want to insert each commit by its, I don't know, hash, let's say. And the other and the stored information is exactly as defined in schema. So we have user there, and we have also the date that the commit was made. So we can have, I'm thinking, yes. So there's a way that the GitHub works with commits. So you have the commit object, and you have also the git commit object, to say it simplicitly. So we're gonna use that, and now we're gonna use we're gonna decide, we're gonna find out who was the author. So the way it works is that either the commit object from the GitHub has the author in specified, so, or if it is not present, there is a nested commit inside the commit object, and that should always have an author in there. So yeah, that's an author there, and there's only an email information. That's about the author. So I can specify here that the knowledge would be, under user would be the author and the date. And that is basically basically the same. I would use the GitHub commit, the git commit date stamp, and yeah, that's it. So yeah, we want to store timestamp, not timestamp object. Yeah. So the way that this works is that there's an iterator over all of the commits we gathered, and for each commit, this information will be stored. Now, also don't have to do anything with this, because the stored entities function returns actually all of the stored commits we did here. And there's the last function, the get raw GitHub data, and that's basically what it says it is. So you want to specify here how to get all of the commits from the repository. So by using the GitHub, we just need to specify a path to the pip file log file. And yeah, so this returns the raw data, and the analyze function I've mentioned earlier filters the raw data to the data that is not yet present in knowledge. So let's say that you extracted information before from the project, and you have something already on your storage, and you want to analyze, let's say, next day, and you find out that there's a new information, but you don't want to analyze the old information that was extracted before. So the analyze function was just for that. So you want to filter only the new entities that will be added to the currently get that knowledge. I will just add a guard here. So if there is no knowledge before, just return all of the data of the raw data from the GitHub. And if there is any knowledge there, we will return the filtered commits. So So for each commit, get the ones that hash is not in the previous knowledge. Damn it. Yes. And by this, it should filter only the new ones. Yeah, actually, the previous knowledge is a dictionary. So you can see that all of the entities that inherit from the entity have some attributes like previous knowledge, the store, the repository attribute, etc. that you can access, and many more other methods that work just for the just for some tool purposes like load previous knowledge and etc. etc. So yeah, this should be done, I guess, and we can try it out. So the way that it works is that you either specify an entity by its name that you've written basically as a class name, or you don't specify any entity and all of the entities would be analyzed. So right now there's a new file, a dependency update in the entities folder, and the CLI should recognize that there's a new entity present. So there should be a logger information out there. Yes, probably not right away. So yeah, I've just canceled it so we can see. So yeah, there's a new dependency update entity under the detected entities. So I can only specify the dependency update entity by its name, and it should only analyze that onto the Zef. Yes, so there's a problem somewhere. Oh yeah, typo. Sorry. And now the analysis is run. So that's about the update on how the entities are now implemented. And I have also a second update on the a new entity that we want to inspect and analyze, and that is a Kebechet manager usage. So let me switch the screens. Okay, can you see anything? Okay, so we have a Kebechet inside our top station organization, and the Kebechet has a bunch of managers that you can use in your project or in your repository. And let's say that one of them is, for example, the update manager. What does the update manager? What does the update manager is that it either automatically. Oh damn it! Yeah, it. I cannot say the word. Sorry. So yeah, it updates the dependencies periodically. So you have an example here that Kebechet does an automatic update of dependency, right? And you have either this or the manual updates done by user. So you can request the update on dependencies. And by this new entity that it would be inspected is the purpose of knowing how much the managers of Kebechet are used within the repositories that use them. So we want to have a information on how often the Kebechet updates the repositories, or what is the ratio between manual updates and automatic updates. So the manual updates of, let's say, a user that or a contributor that manually updates the pip file. So So he does not use Kebechet, and what is the ratio between that and the Kebechet update manager. So we can know on which features to focus. And yeah, that's basically a Kebechet update entity. And the Kebechet update entity just inspects all of the update requests, so the manual one or the automatic one, or also the failed update trial. So yeah, just again, let me switch the windows. Yeah, so that's just that. So I can also do analysis on the Kebechet update manager. So it analyzes the request type when it was created, the pod response, which is that if a human created the request, so it was a manual type, it would measure how fast the bot responded. This will further have a visualization, which is not yet done, so that will be the final proof of concept of this feature. That's basically it. Yeah. So any questions about this? If not, yeah, that's all. Thank you.